Hi everyone, today we are going to start part 1 of the Chapter 4 study guide for our Chapter 4 test. This is part 1, which means I'm going to split this study guide into 2 parts, so please watch this part first and then go to video number 2 to fill out the rest of your study guide. Alright, so question 1, find the value of x, then classify the triangle by its angles. Alright, so I notice here that I have an exterior angle. So to solve for x, I'm going to have to use the exterior angle theorem, which states that the exterior angle is equal to the sum of the two non-adjacent angles, which in this case would just be 20 plus 30. Combine your like terms, 2x is equal to 50, so x is equal to 25. Now to figure out what type of triangle this is by its angles, I need to plug x back into my equations. And actually, I do not need to do that because that would tell me my exterior angle. I know that my angles add up to 180 degrees. So if I'm just missing one of these angles, that means this is equal to 130 degrees. Which means since this angle here is greater than 90, we have an obtuse triangle. So I'll write that here. Number 2, I have 2x plus 5, 8x, and 25. These are all interior angles. So to solve for the interior angles, I know when I add these up, it equals 180. So let's write that out. So we have 2x plus 5 plus 8x plus 25 is equal to 180. From here, I'm going to combine my like terms. So I have 2x plus 8x, that is 10x. Then I have 5 plus 25, that is 30, is equal to 180. Subtract 30 from each side. 10x is equal to 150. Divide by 10. X then is equal to 15. So now for this problem, I do need to plug x back in to find the angle measures of each angle here. So if I plug x back into this first equation, 2x plus 5, I end up getting 35. If I plug x into this equation here, I end up getting 120. So now since this angle is greater than 90, I therefore have an obtuse triangle. Question number 3 is very similar to number 2. So I have interior angles. I'm just going to add them up, set them equal to 180. So 4x minus 5 plus 3x plus 5 plus 40 is equal to 180. Combine my like terms, so 4x plus 3x is 7x. Negative 5 plus 5 plus 40, that means those cancel out, and I have a positive 40 is equal to 180. Subtract 40 from each side, 7x is equal to 140. So that means that x then is equal to 20, and I'll highlight that. So I need to plug x back into my equations to figure out each angle measure. So this angle is 75. This angle is 65. I notice that all 3 angles are less than 90 degrees, which means we have an acute triangle. For question number 4 here, I have an exterior angle here, 8x plus 40. But if I look at my triangle, I don't see any equations inside. However, what I do see is that I have tick marks here on these side lengths, meaning that all 3 sides are congruent. If all 3 sides are congruent, that means we have an equilateral triangle. And if we have an equilateral triangle, that also means we have an equiangular triangle, which means all the angles are congruent. So that means that each angle has to be equal to 60 degrees. So now that I know that, I have a linear pair here. And we know that 60 plus my exterior angle, which is 8x plus 40, is going to equal 180. So let's solve for x. I'm going to combine my like terms. So 8x plus 100 is equal to 180. 8x is equal to 80, which means x is equal to 10. And lastly, we have to classify the triangle by its angles. Well, we said all the angles are congruent, which means it's an equal angular triangle. So I will write that out. Next, in the diagram, triangle QRS is congruent to triangle XYZ. We want to find the measures. Before I start, I want to start matching up what's common between these two triangles. So remember, order matters. So looking at this first triangle, I know that Q is first and X is first in that triangle. Therefore, those two angles are congruent. So I'm going to mark this down. So Q and X. And looking at the diagram, I know Q is equal to 55 degrees because it tells me that, which means X is also equal to 55 degrees. Let's move to R. R is the second letter of this triangle. Y is the second letter of that triangle, which means those two angles are also congruent. So I'm going to mark this with 2 tick marks, mark this with 2 tick marks, and finally S and S and Z are congruent because they're the last letters of our congruent triangles. So S, I'll do 3 tick marks, and Z are congruent. We see in the diagram that Z is equal to 50, so S is also equal to 50. Now before I'm done, I am going to figure out what is the measure of angle R and Y. They are going to be the same. We know that when I add up the angles in a triangle, it adds up to 180. So that means that R has to be 75 and Y has to be 75. All right, so now let's answer our questions. So for number 5, the measure of angle R is equal to, well, if I look at my picture here, I see it's 75 degrees. I'm going to skip 6 for right now, come back to it. Number 7, the measure of angle X. Well, if I look at my diagram, I see that that is equal to 55 degrees. And the measure of angle S, let's look at our diagram, I see that that is 50 degrees. All right, so let's go back to XY. So XY is right here. Let's figure out what segment is congruent to XY. Well, it would be QR. Those two segments are congruent. And if we look at this, I see that QR is equal to 6, which means XY is also equal to 6. In the exercises, 9 and 10 tell whether a rigid motion can move the solid figure onto the dashed figure. Remember, rigid motion means that the figure does not change size or shape, it's just moved around somehow. So if so, describe the transformation that you can use. If not, explain why the figures are not congruent. So I'm going to scroll down a little bit. So let's look at 9. Are these figures congruent, yes or no? Well, the answer is yes, they are the same shape and size. So what rigid motion would be used here? This would be a reflection. They are a mirror image. And it would be a reflection over the x-axis. Now number 10. Number 10, there's going to be 2 rigid motions to make these triangles congruent. Well, they are congruent to make this triangle look like this triangle. So the first one is going to be a rotation. So I did a very bad sketch of this figure rotating to look like this. So after the rotation, there is a reflection. to turn this figure here into our final figure here. For question 11, Jackson describes a transformation in the coordinate plane using this notation. Our xy coordinate changes to a negative x comma y. Explain why this is a rigid motion. Well, remember, this is one of our special rigid motions. This is a reflection over one of the axes, and which one? It's over the y-axis. State the congruence that is needed to prove that triangle ABC is congruent to triangle DEF using the given postulate or theorem. All right, so we're going to have to focus on each of these questions separately because they give us different information, and we're going to have to prove the different postulates. So let's start by focusing on number 12. Ignore 13, 14, and 15. All right, so for number 12, we are given that BC, I'm going to mark this, is congruent to EF. We want to use the hypotenuse leg theorem. Hypotenuse leg theorem, congruence theorem. What additional information do we need here? Well, if I look at my diagram, I notice I have my right angle, so that is good. I also know that I have two legs that are congruent. So all that I'm missing is the hypotenuse. And if you look at this diagram, where are the hypotenuse for each triangle? Right here. And so I'll mark that as AC and DF. And I'm done. All right, so next I'm going to focus on number 13. So ignore 12, ignore 14, ignore 15. So just looking at question 13, we are given that AB is congruent to DE. So AB is congruent to DE. I'm also given that AC is congruent to DF. I want to prove that these two triangles are congruent by the side, side, side postulate. So what additional information do I need? Well, I have two sides of each triangle, which means I need the third side, which the third side would be on this triangle would be BC. And the third side on my second triangle would be EF. And I would be done. Next, let's focus on question 14. So I am given that angle A is congruent to angle D. I'm also given that angle B is congruent to angle E. We want to use the angle side postulate, angle side, to prove that these two triangles are congruent. For this problem, we actually would have two answers. So one answer would be to say that this side is congruent to this side. That would give us angle side. So I'm going to write that out, that AC would be congruent to DF. That would give us angle side. Or, and I'll mark this differently, we could say that BC is congruent to EF. So if I ignore this and I ignore this, I still have angle side. So BC is congruent to EF. So once again, there are two answers I could have for this problem. And finally, number 15. We are given that A is congruent to angle D. We are given that angle C is congruent to angle F. I want to prove that these two triangles are congruent by angle side angle. So what information am I missing? Well, remember, the side has to be in between the two angles. So the only one that would work here is saying that those two sides are congruent. So AC would have to be congruent to DF. Decide whether the triangle can be proven congruent by the given postulate or theorem. All right, so looking at number 16, I want to prove that these two triangles are congruent by the hypotenuse leg theorem. Can I do this? Well, the answer is no. Why? Well, the hypotenuse-like theorem only works for right triangles, and these are not right triangles. So triangle LMN and triangle CBA are not right triangles. Oops. All right, let's look at 17. Triangle TWX is congruent to triangle YWX by angle, side, angle. All right, so let's look at what we know. I see that this angle is congruent to this angle. I also see that this angle is congruent to this angle. But is there any other information that I know here? There is. I do see that these two triangles share side WX. So since they share this side, I can prove that they are congruent by angle, side, angle. So yes, the reason, because they both share side WX. All right, so here's some more questions about solving for x. So we want to find the value of x in each of these problems. So for number 18, I see that I have an isosceles triangle here. How do I know that? Well, I see that my base angles here are congruent. And we know for isosceles triangles, the base angles are congruent, which means these side lengths are congruent, which means I can just set my equations equal to each other. So here we go. 3x plus 15 is going to equal 4x plus 12. All right, I'm going to subtract 3x from each side, and when I do that, I have 15 is equal to x plus 12. Subtract 12 from each side, 3 is equal to x. For number 19, I also have an isosceles triangle. Why do I know that? Well, my two legs are congruent. If those two legs are congruent, that means that my base angles are also congruent. So to solve for x, I just need to set these two equations equal to each other. So 6x is equal to 8x minus 22. I'm going to subtract 6x and add 22 over, so this becomes positive 22 is equal to 2x. Which means 11 is equal to x. For number 20, once again, I see that I have an isosceles triangle. How do I know that? Well, my base angles here are the same. So since the base angles are the same, I have an isosceles triangle. Therefore, these sides are the same. So I'm going to set these two equations equal to each other. So x plus 18 is equal to 3x, which means I'm going to subtract 1x from each side. So 18 is equal to 2x. So 9 is equal to x. And the last problem I'm going to do for part 1 of the study guide is number 21. So if I look at my triangle, I don't have an isosceles triangle here. I have an equilateral. And I see that because all of those tick marks, meaning that each side is congruent. Well, let's think about this. What is one angle of an equilateral triangle? Well, it's equal to 60 degrees. So I can set these two equations equal to each other then. That 2x is equal to 60. Therefore, x is equal to 30.